Welcome to my channel. Today we are going to discuss about the topic is classification of discrete time signals from the subject IT6502 digital signal processing. So already we discussed that basics about the DSP, and the next one is sampling, then classification of discrete time system, MCQ questions we discussed. So today we are going to discuss about the classification of discrete time signals. So first question is what are all the classification of signals? Okay, so what are all the different classification of signals? So the signals are basically divided into two types. One is continuous and discrete time signal. Then all continuous and discrete time signals are further classified into many types. So they are, first one is periodic and non-periodic signal, even odd signal, energy power signal, deterministic and random signal. So these are all the some of the classifications. So out of that, some of the classification, causal, non-causal signal, and so many signal classifications are there. Okay. So first one, continuous and discrete time. So the signal is of having amplitude in all instant of time, means that is called as a continuous time signal. So this is the sine waveform. This is the continuous time signal. The signal is having value in all instant of time. The next one, discrete signal. Discrete signal means the signal is having value at a definite time period. That is for n equal to 1, n equal to 2, n equal to 3. At that instant only the signal is having some value, means this type of signal is called as a discrete signal. Okay. So if you want to learn more about this classification of signal and their corresponding problem in a detailed manner, means so in my channel signals and system playlist is that. Okay. In that all videos are explained, all topics are explained in a topic wise, and so many problems are solved. Okay, so the link for that videos I will give in the description box, you can refer. So the classification, so we divide this continuous and discrete time signal into the further classification, periodic, non-periodic. So the name itself answers that, periodic, non-periodic. Periodic means the signal is of the value, that is after a particular time period, again the same shape is again and again repeating, means it is said to be periodic. So you see this sine waveform. So this is a periodic. So after this particular interval, this positive cycle, negative cycle, again the positive cycle, negative cycle is repeating. So again and again for a definite interval, again and again the same waveform is repeating, means it is a periodic. Then if the shape of the signal is non-repeating, means it is said to be non-periodic. So the exponential signals are example for non-periodic signal. Okay. Then even odd signal. If the even signal means if the signal it's that is about vertical axis. Okay, about y axis it is symmetric, means that is called even signal, or otherwise it's a odd signal. Then energy power signal. If the signal is having finite energy, then that signal is called as energy signal. If the signal is having finite amount of power, means that signal is called as power signal. Then deterministic random. So if some signals are, that is the value of the particular signal we can define. Okay, at that is this signal is having this amplitude in this time, we can determine, means that is that type of signal is called as deterministic, otherwise it's a random. So all our standard signals are deterministic signal. Okay, since we can determine the value of that particular signal. Random means we can't determine the amplitude of that particular signal in particular time. So the example for random signals are that is a noise generated by the particular amplifier. Okay, so if you want to learn more about this thing, I will give link for that video in the description box. Already I explained these topics in a signals and system paper. Okay, so we will see the MCQ question. The second one, what is single valued function? So in maths, you studied single valued function. Single valued function means single value for all instant of time, unique value for every instant of time, a single pattern followed by this one. So four choices given. Single valued function means this. It means every instant of time there is a unique value is there. It is called a single valued function. Then in real valued function and complex valued function, time is dash. So in signal, the time, it is said to be the independent variable. Either it is in a real valued function or complex valued function, time is a real quantity. Okay, time is always real quantity. The next one, discrete time signals is derived from the continuous time signal by dash process. So already you studied the topic sampling. What is the need for sampling? Sampling is used to convert a continuous time signal into discrete time signal. So that is the question. The discrete time signal is derived from continuous time signal by dash process, sampling process. If you are performing sampling of continuous time signal means we will get discrete. The continuous time signals are can be defined as x of t. Discrete time signals can be represented by x of n. Then next one, a signal which repeats itself after a fixed time period is called as dash. It's a periodic signal. So already uh, that it is we discussed the periodic, non-periodic. The signal which repeats itself after a fixed time period. After a fixed time period, again the same waveform is repeating means it is called as a periodic signal. Okay. Then the next one, a signal which does not repeat itself after a fixed time period. It is called as a non-periodic. Okay, if it is not repeating means it is called as a non-periodic. Then the next one, the DT signal. DT means, discrete time signal. The discrete time signal is periodic if it should satisfy the condition. What is the condition? Okay, so in order to check the given signal is periodic or not, that signal, it should satisfy some condition. So what is that condition means? X of n is equal to x of n plus capital N. Okay, if the original signal x of n and x of n plus n, if both the values are equal means we can say that it's a periodic. If not equal means we can say that it is a non-periodic. Okay, then this x of t equal to x of t plus t, this is for in order to check the periodicity of continuous time signal. This is for discrete. Then the next one, when x of n is said to be non-periodic. Okay, when x of n is said to be non-periodic. So already if x of n is not equal to x of n plus n means it is non-periodic. So here you see the choices. If the equation x of n equal to x of n plus n is satisfied for all value of n, this is for periodic condition. Then if x of n is equal to x of n plus n is satisfied for no value of n. Okay, this is the correct thing. Or otherwise, x of n is not equal to x of n plus n means it is non-periodic. Then the next one, the exponentially damped sinusoidal signal is dash. So exponentially damped sinusoidal signal means the signal is having exponentially decaying amplitude. Okay, the sinusoidal waveform, but the amplitude of the sinusoidal waveform is exponentially decaying. So this type of waveform is which signal? Non-periodic. So you see the shape and amplitude is decreasing. So it's a non-periodic signal. Then the next one, which one condition is true to check the periodicity for discrete time signal where k is any integer, n is the period, f naught is the frequency. So in order to check the given signal is periodic or not, if the particular signal, the frequency f naught, it can be expressed as a ratio of k divided by n, where k and n, if both are integer means we can say that the particular signal is a periodic signal. So this is a very important question. If the signal is, one discrete time signal is periodic means the frequency f naught, it can be expressed as a ratio of two integer k divided by n. Then the next one, discrete time signal is periodic if the frequency f naught is rational. Rational means the frequency f naught is the ratio of two integers. Okay, you see f naught is equal to k by n, where k is an integer, n is an integer means that particular signal is periodic. So the statement is true. Okay, the statement is true or false, it's a true. Then next one, the problem related with the periodic and non-periodic. This is the important two more problem. So we will see the three problem. So if you want to learn more problems means I will give link already. I solved many problem for this periodic, non-periodic in a signals and system playlist. I will give link for that video. You can refer if you want to learn more problem. So here the question is x of n is equal to 2 cos 2n is periodic or not. Okay. So the four choices given: periodic with the period 2n, periodic with the period 2 pi, periodic with the period 2, non-periodic. So which one we can see? So first one, if the given signal you just write. Okay. So in order to check the given signal, the given discrete time signal, sine and cosine signal is periodic or not means first we have to calculate the value of f. Okay. If the f, it can be, we can represent the frequency f as a ratio of k by n. If the k and n value both are integers means we can say that the given signal is periodic. Okay. So what is the standard cosine waveform? You know, the standard cosine waveform is a cos omega n. Okay. So cos omega n, this is the expression for standard discrete cosine signal. So you just compare this 2 cos 2n with a cos omega n. Okay, you just compare it. If you are comparing these two equations, so in the place of omega, which one is available? 2 is available. So we want only the frequency term, amplitude no need. So omega equal to 2. So what is omega? Omega is nothing but we can expand as 2 pi f. So 2 pi f is equal to 2. So from that f is equal to 2 to cancel 1 by f. So we can represent what is f? F can be represented as a ratio of k by n. So according to this, the k value 1 but n value pi. So 1 is an integer but this n equal to pi is not an integer. So the f naught, the frequency f naught is a irrational number. So irrational number means f naught is not a ratio of two integer. So if f naught is not a ratio of two integer means we can say that the given signal is non-periodic. So the signal is non-periodic. Okay. So simply if you are saying means in that is if the given sequence x of n is single sine and cosine signal means if in the omega term pi is available means it is periodic. So here no pi is available. So it is a non-periodic. Okay. So similarly you see the next problem. Check whether the x of n is 7 sine 6 pi n is periodic. If it is periodic, calculate the fundamental period. Okay. So here you see sine 6 pi n. Here one pi is available. So the signal is a periodic. But we have to find out the fundamental period also. Okay. Fundamental period is nothing but this capital N value. Okay. So the same thing. So you just write x of n. So we have to compare this sine omega n. Okay. We have to find out the value of f. So in order to find out the f, we have to find out omega. So omega is nothing but 2 pi f. So in the place of omega, which one is available? 6 pi is available. So pi cancel, 2 here, 3 cancel. So f can be represented as 1 by 3. So where k is a 1, n is a 3. So k and n both is a integers. Okay, k and n both are integers. So it's a ratio of two integers. So it is called as rational number. So if f naught can be represented as a ratio of two integer means we can say that the given signal is a periodic. Okay, so here in first three choice periodic is given but with a different fundamental period. So which one is correct we have to find out. So the fundamental period is nothing but this capital N value. So what is the value of capital N? 3. So that's why the answer is the given signal is periodic with the fundamental period 3. Okay, so this is a important 2 mark problem. Okay, in periodic, non-periodic, they will ask find out the given signal is periodic or not. If period means find the fundamental period. Okay, you just find the f value. If f is the ratio of two integer means periodic. If f is not a ratio of two integer means it's a non-periodic. Then the next question, which one is discrete time periodic signal? Okay, so here you see the x of n. Okay, check whether the signal x of n equal to cos n by 2. So here you already I told you know in the omega part pi is not available means it's a non-periodic. Okay, so it's a non-periodic. So the same thing we done. X of n you just write. So in the place of omega, which one is available? 1 by 2. So what is the f? F is nothing but 1 by 4 pi. So k is integer but n is 4 pi. 4 pi is not an integer. So it's a irrational number. So the given signal is non-periodic. Okay, then the next one, if x of n is equal to cos n pi by 2 plus cos n pi by 4, then the sequence x of n is dash. So here you see in the given problem, the sequence consisting of two cosine sequence. Okay, if the single sequence given means already we solved the three problem. Okay, in that you just find f value. If f is a ratio of integer means periodic, otherwise non-periodic. But sometimes the given signal consists of two cosine sequence, two sine sequence, or one cosine, one sine. Means in order to check the composite signal is periodic or not, we have to find the ratio n1 divided by n2. So what is n1 means fundamental period of first signal. N2 is the fundamental period of second signal. Okay. Then if this ratio is ratio of two integer means the given signal is periodic or otherwise non-periodic. Okay, so you just write the cos n pi by 2, you take it as a x1 of n. This cos n pi by 4, you take it as a x2. Okay, so then from that, you have to find out capital N1. What is capital N1? We can represent f as the ratio of k by n1. So from that, what is the omega 1 part? Pi by 2. Okay. So from that, the omega 1 can be written as 2 pi f1 equal to pi by 2. So pi cancel. So f1 equal to 1 by 4. So from that, the capital N1 value is 4. Okay. Similarly, x2 of n is cos n pi by 4. From that, you equate and we have to find out the value of n2. Okay. So n1 is 4, n2 is 8. Okay. Then the next step is we have to find the ratio n1 by n2. So n1 is 4, n2 is 8. So if this ratio n1 by n2, it can be as a ratio of two integer. Yes, 4 is an integer, 8 is an integer. Means the given signal is a periodic. So this given signal is periodic. Okay, with period, we have to find out the period. Okay, it's a rational number. So the given signal is periodic. So the fundamental period is given by, it's a LCM of the n1 value comma n2 value. So LCM of 4 comma 8, the answer is 8. So the given signal is periodic with the fundamental period 8. So the answer is, you see, A. Periodic with the period is 8. Okay, so this is the way in order to solve this problem. Okay, then the next one, the next classification, energy and power signal. For an energy signal dash, for one energy signal, the power value, it should be 0. Okay, just remember it. This is also an important thing. For one energy signal, energy value is finite, power value is 0. Okay, if signal is said to be energy signal, if energy E between 0 to infinity, that is finite value, but a power value equal to 0. Similarly, for power signal, the energy value equal to infinity. So one signal is for a power signal, the power value finite, but energy value is infinity. Okay, so these are all the conditions for power and energy signal. Then energy signal has 0 average power and power signal has 0 energy. This is true or false? False. Okay, so already we discussed power signal has infinite energy, but energy signal has 0 power. Okay, but here the statement is given, energy signal has 0 power, power signal has 0 energy. So this is the wrong statement. Then the next one, unit step signal is a dash. So unit step U of n. The U of n is a energy signal, power signal, neither energy nor power. It's a power signal. Okay, so you just remember the thing. Already we solved this. We can calculate this unit step signal as energy or power. Already this problem is solved as a separate video in signals and system. Okay, if you want to learn, I will give a link for energy and power signal problem. Video, you can check. So unit step signal is, you just remember it, it's a power signal. Then the next one, x of n equal to a power n u of n is dash. X of n equal to a power n u of n. It's a exponential signal. Okay, discrete exponential signal. That signal is the energy signal. Okay, so you want the proof means I will give link in the description box. You can see. Then the next one, discrete ramp signal. Ramp signal R of n. It's a neither energy nor power. It's not an energy signal. The power is all, that is the energy value is not, is also infinity, Power value is also infinity. So it's a neither energy nor power. Okay. So you see, this is the formula in order to calculate the power. Okay. The power formula is nothing but limit n tends to infinity 1 by 2n plus 1 summation minus n to n x of n the whole square. Okay. So in this formula, you just substitute the value of x of n. If you are solving, we will get the power is infinity. Then energy we can calculate. This is the energy formula. If you are calculating energy also, energy is also infinity. So both energy and power is infinity for ramp signal. So it's a neither energy nor power signal. Then the next question, discrete unit step signal is a power signal. So unit step is power signal. Exponential signal is a energy signal. Ramp signal is a neither energy nor power signal. So this is the unit step signal problem we derived. Okay, so using the power formula, in a power formula, we have to substitute the value of x of n. So if we are substituting, we will get the answer is power is equal to 1 by 2 watts. So since the power is finite, the given signal is a power signal. So U of n is a power signal of power is 1 by 2 watts, 0.5 watts. Okay. Then the next one, the signal x of n equal to del of n is dash. Energy, power, or neither energy nor power, none of the above. Del of an impulse signal. Impulse signal is a energy signal. So you see the energy formula summation n equal to minus infinity infinity x of n the whole square. Here what is x of n? The x of n is nothing but del of n. So you know the del of n nature. What is del of n? Del of n is having the value 1 at only the time n equal to 0. So that's why this summation for n equal to minus infinity infinity, only at n equal to 0, this x of n is having the value 1. Okay, so that's why the answer is 1. So energy is finite. So impulse signal is a energy signal. Okay, then the next one, signal which can be described by mathematical formula, lookup table, some well-defined rule are known as deterministic signal. Okay, so we discussed the third classification, you know, deterministic and random. Deterministic means the signal which can be defined either mathematical formula or lookup table or graphical method. We can represent one signal means it is called as deterministic. All standard signals are deterministic signal. Then the next one, a deterministic signal has no certainty. Okay, no uncertainty. Then the next one, the noise generated by an amplifier of radio is an example for random signal. So the noise generated by all electronic equipment, it is an example for random signal. Okay. Then the next one, which one of the following is used to check the discrete time signal is even? So the fourth classification, even and odd signal. Okay. So first we discussed periodic, non-periodic, then energy, power, then deterministic random, then the fourth one is a even odd. Okay, even means symmetric signal. So what is the condition in order to check the discrete time signal is even? X of n is equal to x of minus n. If one signal satisfies this condition means it is a even. Okay, so x of minus n means folded signal. If original signal and the folded version both having the equal value means it is a even signal. Then the next one, even signals are symmetric about the vertical axis. Yes, it's a true. Even signal means the original signal and folded. Folded means about this vertical axis. If you are swapping the value means it is called as the x of minus n. So even signals are symmetric about the vertical axis. Then the next one, x of minus n equal to x of n. Then the signal is said to be even. Okay, what is this condition? This condition is for even signal. Then which one of the following is used to check the discrete time signal is odd? Okay, some signals are even category, some signals are odd category. So what is the condition in order to check the signal is odd? X of n equal to minus x of minus n. Then the next one, what is the even component of discrete time signal? So in a signal, each signal is having some amount of even part, some amount of odd component part. So if we want to find out the even component of discrete time signal, the formula is that x e of n is equal to x of n plus x of minus n divided by 2. Okay, this is the formula in order to find the even component of discrete signal. The first two thing is the formula for continuous time signal. The next one, what is the odd component of discrete time signal? So the odd component is x O of n is equal to x of n minus x of minus n divided by 2. Okay, we have to subtract original signal and folded signal, and divided by 2 means it is said to be odd component x O of n. That is we are having some problem in the even and odd signal also. So determine whether the signal x of n is sine 2 pi n is odd, even, neither even nor odd. Okay, so what is the condition in order to check the given signal is even or odd? So first we can find out that is x of n, you just write this is the x of n. Then we can determine x of minus n. What is x of minus n? In the given x of n, you just replace n by minus n. So sine of minus 2 pi n. So what is sine of minus 2 pi n? It's a minus sine 2 pi n. Okay. So here you check x of n and x of minus n is equal or not. Not equal. One minus is came. So what is the condition means? So the given signal, it satisfies the condition x of n equal to minus x of minus n. So this is the condition in order to check the given signal is odd. So the given signal is a odd signal. Okay. If x of n, x of minus n value equal means even. If x of n equal to minus x of minus n means it is odd. So sine signal is a odd signal. Then the next one, determine whether the signal x of n equal to cos 2 pi n is even, odd, or neither even nor. So cos 2 pi n, it's a even signal. So you just see, similarly you can verify x of n equal to cos 2 pi n. What is x of minus n? Cos of minus 2 pi n. What is cos of minus theta? Cos theta. Okay, so same cos 2 pi. So x of n, x of minus n, or both are equal. So it's a even signal. Then the next question, time scaling is an operation performed on dash. Okay, the time scaling, it is nothing but it's the operations performed on the signal. So is the operation performed on dependent variable, independent variable, both dependent and independent variable, neither dependent nor independent variable, independent variable. The time scaling is the process. The time n is multiplied with some scalar value 2 or 3. Okay, x of 2n. So this is called as time scaling, or x of n divided by 2. It's a time scaling. So time scaling is an operation performed on independent variable time n. Okay, so these are all the some of the questions from the classification of discrete time signals. Okay, so if you want to learn more about this discrete time classification, so I posted the separate videos for periodic, non-periodic signal classification, separate one video I posted. Then for even, odd signals, so many problems are solved. And energy and power signal also I posted the separate video. So I will give link for that videos in the description box. You can see if you want to learn more. Okay, so thanks for watching my channel, and please subscribe my channel for more videos. Okay, so we will meet in the next video. Okay, so thank you.